All right, so we started factoring trinomials. Okay, highest degree is first. So we did grouping where we multiply to AC and we add to the middle term. We group it, we GCF, we put it together. Notice that the order doesn't matter. Okay, so we kept going, and you're like, oh, sometimes that list gets really long. Okay. Now, if your numbers don't show up on the list, we say it does not factor. Okay? That's one way to figure out that something might be prime. Prime means does not factor. Okay? Now, the second thing that we looked at to try to avoid all of the grouping work, okay, was sort of guess and check. Okay? And so this is what we're looking at here. Notice that we are considering, right, there's only one way to multiply to get x squared, and that's x times x. And then you can kind of look at the last term. Multiply to get -6. Add to get -1. And so we choose our numbers, okay, by looking at what numbers go together to get first, outer, inner, last, okay? So we keep going, and as you get numbers in front, it gets a little bit trickier, okay? So right here, how do you multiply to get 3x squared? 3 times 1. How do you multiply to get 5? 1 times 5, right? Maybe you still have a lot of guess and check to do. So you still consider what your inner and your outer are supposed to be. Multiply AC. That gives you 15. Add to 8. That means that my inner and outer terms are supposed to be 5 and 3. Okay, so notice, multiply to get the first. Okay, multiply to get the last. And inner and outer check. All right, so I'm going to flip here, 7, 8. And we're just going to do an example here, just to sort of remind us of what we're doing. Okay, so we left off with okay, 2x squared minus 19x plus 42. Okay. So I'm going to look at my numbers. In order to multiply to get the first term, it's 2 times 1. It's my only choice. Multiply to get the last term is a little bit trickier because 4, 5, 6. Okay, there's a lot of choices here. I don't know if I can guess and check that many different things. Okay, so I'm going to put my parentheses down here, and I'm going to go ahead and place the one that I'm like certain about. 2x times 1x. And I could sit here and I could go back and forth trying all of these combinations to see if I can get to -19x. But it's like a lot of process of elimination. So I'm going to do this. I need more. I need more to go with because there's a lot of choices here. So we're going to multiply to 84. I want to know what my inner and outer are supposed to be. Okay, and we're going to add to -19. This is going to give me my inner and outer. 3, 4, 5, 6, 7, 8. Okay, not sure how many combinations I need to come up with. So let's see, does 84 divide by 3? Yes, it does. Okay, yes.
Why would you do that instead of just do the process of elimination for the 32?
Depends on what you're more comfortable with. There's kind of a lot of choices here. If I had fewer choices in this list, I would probably just switch them around and figure it out. Okay? I'm going for a little more information. I want to figure out what my inner and outer are supposed to be. Okay? So 84 divided by 3. All right, so 28. Okay? Times 2, divide by 2. 5 doesn't work. Times 2, divide by 2. Okay, so that's good. 8 doesn't work. 9 doesn't work. 10 doesn't work. I think I've got them all. Let's try 7. Okay, 70, 77, 84. So 7 does work. I didn't even do division. I just started at the closest multiple and sort of counted from there. Okay, here it is. 7 and 12. -7 and -12. This is your inner and outer numbers. Now you have more to go with. 1 second, Alex, and then I'll get your question. Okay. I want to make my outer minus 12x because -7 doesn't seem to fit. Who can tell me why -7 doesn't fit as the outer? We'll go, Sasha. Because you can divide it by 2 nicely. Perfect. Okay, so 2 times what gives me -12? Yes, -6. Oh, look, it's on my list. So, Duncan, you were like, why don't you just guess and check? This sort of narrows it down a little bit to what numbers you're going to use. Okay?
6 and 7 don't add up to...
They multiply to 42, but look at how your foiling works. Your outer becomes minus 12x, and your inner becomes -7x. So it does work. All right. Yes, Ran. Sure. Alex, what was your question?
So the maximum number you check for multiplication is like 12, right? If it's past 12, it doesn't work.
Mostly I just, okay, here we go. 10. Obviously 10 doesn't work.
If it had a multiple by 13, would that...
No, here, no, I got you. Watch this. Okay. So you see here how 10, 11, 12, 10 doesn't work, 11 doesn't work, 12 gets you right back to here. That's how you know you've gotten all the possibilities.
Okay, but would there be certain numbers that wouldn't get you back to a specific number? Like what?
No, it's basically always going to make a complete circle.
Okay, thank you.
Yes. Okay, here we go. Let's try this one. 5x squared plus 16x plus 12. All right, so we've got first, so we've got 5 times 1, okay? We've got last, which is 1 times 12, or 2 times 6, or 3 times 4. Okay, yes? Yep. Okay. And I just put my parentheses down, and I give it a try. Right? If you need more information from here, then you can start looking at what the inner and outer are supposed to be. Yeah, sometimes I just can't do that much thinking. Literally. Okay, so like I try to narrow my choices down here. So I'm going to multiply to 60. Four, nope. 5, yes. 6, yes. Oh, perfect. Right, if I find the numbers, I don't make the rest of my list. Okay, inner and outer. Notice the orange and the pink, that's just guess and check. Like, what numbers am I allowed to use? The blue, that is actually working out what the FOIL is supposed to be. Okay, well, I've already got the 5 and the 1. I'm like, oh, See, like I know, I can already see the answer. All right, who can tell me what you want to do next? Question or?
Answer.
Okay, yes, go for it.
So you want to use a 10 to compare with the 5 because 10 divided by 5 is actually easy to 2. If you use the 6, that would be kind of hard to.
Yeah, it would not be an integer. We like integers. Okay? All right, next. What am I going to do next?
Sorry,
Yep.
I have a question.
Yep.
Where is the multiplying by 10 coming from?
This one?
Yeah.
Oh, okay. This is not multiplying. It's 5 times 2 is 10x.
That makes sense.
Okay. All right. Just go. Yes, Lori.
So, our other integer would be 6 because you have to multiply the x's with nothing, so it's just 1, so 6 times 1 is 6.
Yes. Okay. So there's my inner and my outer. Check. Okay. And I'm looking at my signs. Positive and positive. Notice that we got 6 times 2.
I'm pretty confused on how you got the 2 still.
This 2?
Yeah.
Okay. Here we go. Ready? Okay. So I'm going to put my 5x and x.
Like, I understand that it multiplies, but like, how do you figure out?
Okay, so here you go. This is straight up guess and check right here. 2 and 6, 6 and 2. Because really it could be any of these potential numbers, which you see is quite a bit to like go through, right? Okay, does that make sense, Eve?
Yeah.
Okay, so I don't like having to check that many different combinations. So I come over here and I figure out what my inner and my outer are, which is 6 and 10. Okay? So if I have to have a 5 here, so 5 times the outer and 1 times the inner, which one of these things, outer or inner, can you easily get to 10?
6.
Okay, so 5 times 2 is 10, and 1 times 6 is 6.
Okay, yeah, sorry, I thought you were.
Does that make sense?
Yeah.
Okay, so it's basically me trying to figure out how not to check all 6 of those possibilities. All right. Okay, you guys ready?
Sure.
Maybe? You can always go to grouping for the ones that seem like there's too much to check. All right. Let's see what we were labeled. Was that? I know. Right, that was basically A, so we'll go B, patterns, factoring, factor patterns. All right, we have one pattern that we're going to look at here. It's called difference of squares. Okay, so I'm going to start by writing down 2 perfect squares that are subtracted. Okay. And what we're going to do is a little investigation here. Okay, I'm going to write it like this. I'm going to highlight this because this is basically a rule. Things that are highlighted you should probably memorize. Okay, so squares. A squared and B squared. Those things are squares. And then it says difference. Difference means subtract. subtract perfect squares. So that's what I'm doing, okay? And in order to show you that this is how it factors, we're going to do a little FOIL here. First, outer, inner, last. I like to do alphabetical order with my letters. Makes it easy to combine. Notice that my inner and outer are opposites. Right? Same numbers, except the signs are opposite. And so it simplifies to a difference of squares. Wow. Okay. Two. Sum of squares. Does not factor. Right? There's no way to get a positive in between these numbers and have no middle term. So, does not factor. You can think of this all you want. Right? What signs can you put there to make this work? None. There's nothing. Can you do both minuses? No. Right? Does both minuses work? No, because then you get minus AB and minus AB for the middle term. That's not missing. That's not 0. Can you do pluses? No, because then my middle terms are doubled. They're not gone. And so the sum of squares does not factor. Right? Because you got to multiply to get A squared. That's A times A. You got to multiply to get B squared. That's B times B. But the middle term doesn't work. Yes. Question?
Oh, couldn't you just do plus and minus and that would?
Plus, yes, plus and minus. But what's a negative times a positive?
A negative.
A negative, not a positive.
Oh, gotcha.
So the sum of squares does not factor because there's nothing I can do with those signs to make all of the pieces connect. Okay, so let's do some examples. Examples. Okay, we'll start simple. X squared minus 9. All right, so I'm like, kind of look like perfect squares. Okay. So I'm just going to square root them, right? The two pieces, yes, they're perfect squares. Okay. That means that the inner and the outer have to cancel out. How do you multiply to get x squared? X times x. How do you multiply to get 9? 3 times 3. Everything you've already learned still applies. This just happens to be kind of narrowing my choices because it's a pattern. All right, minus, plus. Oh, look. It doesn't actually either or. Okay, good question. Or it doesn't matter the plus or minus order. It's just one of each. Okay, so outer, inner, cancel. Right, 4x squared minus 25y squared. Ooh, extra letters. That's okay. All right. I do notice that one, it's not a trinomial, right? That means that the middle term is 0. And so I'm going to check by square rooting it. Okay, yes. Perfect square. Perfect square, right? So it's a difference of squares. Okay. So 2x and 2x. 5y and 5y. Yes, question.
So do you not worry about the negative sign that's in the middle?
Yeah, because I'm already saying difference for subtraction of squares. So what I'm doing here is just checking to make sure that the square root actually simplifies nicely. Okay, difference. So 1 minus, 1 plus. Okay, I'll do an easy one here. Okay. Let's try 121 minus 9x squared. Like, oh, Miss T, it looks backwards. Yeah, see how the x isn't first? I like to factor in standard form. So I'm going to switch the order. I like my x's in front. I'm going to see this negative. I'm going to take the greatest common factor of a negative out front because I want to start with a positive number. Oh, there's my difference of squares. Okay, so negative. All right, so here is 11 times 11. Here is 3 times 3. Oh, that's how I'm going to get my middle term to cancel out. 3x minus 11, 3x plus 11. Maybe you're like, can't I just do this? Yeah, you can. Right? Maybe you didn't change the order. It's not wrong. I just have a preference for putting my x in front. So you need to know how to do that. If I ask you to start with standard form, which is x is in front. We'll go in the back and then we'll come up. Sure, could you redistribute? Yeah. Negative 3x plus 11. Yeah, you can, but let's say if you want to completely factor, usually you always try to take out the greatest common factor, which would include a leading negative. So every time there's a negative in front, you want to pull that out in front before you start the rest of the factoring. So I would say it's either this, the way I wrote it here, or it's this. Likely I wouldn't mark it wrong as long as what you wrote actually factors or multiplies to what it's supposed to. Okay? All right. Yes, up front.
So, when you have it where the number is in front or before the x, like, you know, where it's
Yes.
number minus x, that is when you negative it, right?
Yes.
Okay, thank you.
We'll say change the order. Okay. Now it gets fun. Yes?
You have the plus and the minus so that they cancel out.
Yes, the plus and the minus is so that when I look at the outer term of 33 and the inner of minus 33, they cancel. Oh, sorry. Okay, the outer of positive 33x and the inner of minus 33x, so they cancel out. Even if I check this one, outer is positive 33, inner is minus 33, it will still cancel out. Okay. So close. 4. All right. X to the 4th minus 81. Okay. Little tricky because I've got a higher power. So the first thing I'm doing is I'm checking to see if they're perfect squares. They are.
Can't you square it again?
You can. So hold that thought because we are going to do it twice, but we're going to do it one step at a time. So this right here is going to go x squared minus 9, x squared plus 9. That's my first round. And then I look at it, I'm like, they still look like perfect squares. So do it again. Why not? This one right here is difference of squares. Keep going. This piece is a sum of squares, not factor. Right? That one doesn't factor, so you leave it alone. However, this first parentheses does factor. So now that I get the hang of it, I don't even write the rest of the work. Right? If patterns are faster. Yes? Yes, yes. Difference means subtract, plus means add or sum. This is it.
Why do you add on that last part?
That's still part of the answer. It doesn't disappear. Okay, so good questions. Let me highlight. So this part turned into this, whereas this piece just stayed there. Does that make sense? Okay. Yes.
What if it was like x to the 6?
Ooh, okay, let's do an x to the 6th. Okay, x to the... I'll do more. I'll make it a 12. Hold on, I'm thinking. Ooh, okay. Minus 16. All right. Now, to start, you're like, is that a perfect square? Like, I don't know, maybe. Okay, so that's x to the 6th times x to the 6th. So it is a perfect square. 16 is 4 times 4. So that is a perfect square. All right, so first round. X to the 6th minus 4. X to the 6th plus 4. Okay, keep looking. That is a difference of squares. So keep going. This one, the sum, doesn't factor. Okay, so here, I guess I can do some scratch work. So the square root of x to the 6th, yep, that's x cubed times x cubed. Okay, square root of 4 is 2. Okay, x cubed minus 2, x cubed plus 2, leave the last piece. Okay, this orange part turned into this. The pink part just stayed. Yes, Sasha.
Is there a way to multiply them all together at once, or do you have to?
Okay, so when you have more than 2 things to multiply, you actually only pick 2 at a time. Doesn't matter what order? No, but I would always pick the things that first. Okay, question.
So, when you multiply exponents, you add the actual exponents, and divide, you subtract, right?
Yes.
Thank you.
Okay, yes.
How do you get the 4?
This 4
No, like when you do a square root of 4.
here?
Yeah.
Oh, I was checking these 2 terms, the difference, right? The difference, the subtraction part. I was checking to see if x to the 6th and 4 were perfect squares so that I could use the pattern. Is that okay? A, B, C. All right, I guess I have to show you one more thing. And then we're done. No more practice. Perfect. Square trinomial. Okay. Perfect square. Okay. This is the quantity. There's the square. Okay. So we're going to FOIL it. First, outer, inner, last. Notice how my middle two terms are the same. So we end up with a squared plus 2ab plus b squared. This is called a perfect square trinomial because it comes from squaring the quantity a plus b. So when you have a perfect square trinomial where that middle term is doubled, not 0, it factors like this. This is called a perfect square trinomial because it can be written as a perfect square. Well, this is one pattern here. We're going to do the exact same 4 lines, but we're going to put a minus. And we FOIL. Minus AB plus B squared. Okay. This is also a perfect square trinomial because it factors into a perfect square, right? 9 is a perfect square because it's 3 times 3. This thing is a perfect square because it's a minus b times a minus b. Any perfect square is when you multiply the same two things together. Okay, so let's do our example. Okay. 4x squared plus 12x plus 9. Okie dokes. Well, you're like, I don't know what this is. Let's try factoring it. Multiply to 36. Ooh, add to 12. Right, it's still a trinomial, guys. It still factors the normal way. Just happens to be a pattern when we get there. Notice how my inner and outer are exactly the same. That means that when I multiply this together, okay, so let's just think about this. I got to multiply to get 4. So let's go 2 and 2. I got to multiply to get 9. That's 3 times 3. Why would I want to pick the same numbers? Because my inner and outer are exactly the same. So pick the same numbers. Okay, so we get 2x and 2x, 3 and 3. Look at that, 6x and 6x. Oh, it happens to be the same factor. That means that this was a perfect square trinomial. And so we're going to write the answer 2x plus 3 squared. Because it's the same factor twice. So what do you have to take away from a perfect square trinomial? Same factor twice. That's all it is. Same. Yes, Duncan?
Why can't we just solve that like normally?
You can. You can definitely do it the other way.
So we could have just.
This is more of a vocab than a factoring technique. Okay? Is it a perfect square trinomial? Yes, because it's the same factor multiplied twice. So this is more vocab than a different way to factor. Okay? Oh, look at that. All right. Last one. Okay, 4x squared minus 20x plus 25. Right? I'm looking at that. I'm like, 4x squared and 25 seem like perfect squares. Maybe I want to start there first for my guess and check. If it works, great. If not, move on. Okay, so multiply, right? Multiply to 100. Ooh, 10 and 10. As soon as your inner and outer are the same number, that's a big clue that this is something special. Okay, so I'm going to put my parentheses down, and I'm going to see what I come up with. All right, so this is 2 times 2, and this one is 5 times 5. Notice that that gets me to the 10 that I was hoping to find. So 2x times 2x, be careful on the minus. Minus 5 minus 5. So 2x minus 5 squared. The perfect square trinomial is something you can check before you do the other factoring.